So these are certain key principles. Already we discussed about holism. What is holism? Systems should be viewed as a wholes, not as a collection of parts. We should not take, we should not discuss, suppose one system is there, we should not think that it is my wings project, it is their wing project. It is not like that. We all are party to each and everything happens in Airport Authority of India. So all of us part of something. So you may have a, suppose you are doing ASMC's project, the stakeholder mainly the runway lighting system, how it is going to be integrated. Definitely electrical people are going to be part of the system. ATM people, those who are using the system is going to be part of the system. There are so many engineering, electrical, each and every person in the area, Airport Authority of India will be party to this system. That is what it is being told as a holism. You should not view isolatedly for any particular domain. In that case, you will end up in a trouble in the last 11th, means last mile connectivity, you will have a problem. Why we need to do this? If we do like this, we can identify and address issues that may not be apparent when looking at the individual components. Individually, you may see, yes, my people are good, they can do this. But when you connect everything, the new situation will arise. So you should always follow the holistic approach. We discussed about emergence. Already we discussed, but still, it refers to the properties or behaviors that arise from the interaction relation between the system components. You can just visualize the chemical components. Chemical component, if you keep individually, it will have different characteristics. Once you mix one or two chemical acids, then it will give a new type of behavior which is not visible when you see those components individually. It's very much applicable to our aviation system also. For example, you take the individual bird flying over the airport and compare with the flock of birds when they are flying over airport. It makes a lot of difference. Similarly, performance of a software system under load. See, we may take a new automated system. Say it may have 150 consoles, 150 workstations. We may not do it a test bed analysis with the 150 system. During the deployment phase, you may do with a 10 system or 15 system. So once you go to the real situation, the software may not be able to handle the load. So how do we do all these things? That's what emergent properties we need to consider. Why this is very important? It's very crucial for ensuring the system performs as intended with a full feature. The next principle, system interactions. We talked about so many components. Okay, how these different parts of system connect and work together to achieve the system's goal. So as I told, we are also part of the system. We are also a system component. How do we interact? Internally, we interact within the system. There will be internal interaction. There will be external interactions, which is beyond your control. So that the environment is one of the factors. Sudden rain comes, huge rain comes, and suddenly your ATM tower is getting leaked, or your ACC is getting leaked, or your equipment is getting leaked. These are all environmental issues. You must anticipate all these things. So what is the advantage of doing this analysis in identifying potential point of failure? Say for example, for radar, we may think that radar antenna is a motor driving system may be a single point of failure. But the particular radar design, suddenly when it fails, then only you will understand there are some other single point of failure. It may be applicable to runway lighting system also. It can be applicable to any other major system in the airport operation or ATM system. Now we will discuss about, once we talked about, so far what we discussed about system, what is system approach, what is system engineering, and why we need to do the system engineering approach, what way it is beneficial, what are the system life cycle, everything we were discussing. We also need to little bit understand what is system thinking and how it is connected with the system engineering. I would like to correlate with some examples so that you can easily understand. First, when we do like this, it is emphasize the understanding of the system as a whole, considering all interaction and the emergent properties. Then how it integrates and how it interacts. Those things also you will understand. So, for example, let us take problem definition. Just you are beginning of the project. You are defining the problem. What is system thinking will help? It will help you to understand the problem context, identifying all the stakeholder, defining the system boundaries, what is included, what is excluded, everything you will do with a system thinking. If you do not have system thinking, you will not be able to see the holistic view of the entire system and the components. So once you understood what is system engineering does, it is helping to develop clear and comprehensive requirements so that this thinking is applied into the development. In each stage, it is applicable. When you work out a solution synthesis, system thinking helps you to explore multiple solution and alternative solution. System engineering, what it does, it gives the structured methodologies to evaluate and select best solution. These two things I will concentrate more when we discuss further so that you will be able to understand. Now, analysis and optimization. You identify so many solutions. Now, what you will do? Understanding interaction and the dependencies of this, whatever the components that you have made. When it comes to system engineering, it gives the analytical tools and techniques to optimize the system performance management, manage the risk of those components. So it is first basic fundamental is that you should not be narrow-minded. When you do a major project, you should be open-minded. You should be able to see the entire thing as a, you should see yourself as a part of the system. And you should see your system also part of your then overall bigger system. Then only you will be able to do system thinking. Then further system engineering concept will help you. Life cycle management we already discussed. Once you see the system thinking, you will be able to understand and appreciate the entire life cycle of the system, like I explained in the previous slides, conception to disposal. Then system engineering, that is implements the process and practices to manage these entire life cycles. So improved problem solving. What are the benefits? This is what I'm saying. Once you do this approach, let it be anything. Say for example, a major project you may do. Suddenly last month before commissioning, broadband connections or some IT networking connections, then also it will affect. So once you think in a larger level, the problem if you define perfectly, naturally you will go towards a solution also effectively. Then once you understand the systems view and you put a system thinking and system engineering, you will never miss any stakeholder. Like I explained just now, telephone connection or IT connection. You will never miss any of the stakeholder. Everybody will be with you so that the project can be perfectly commissioned in time. Similarly, once follow these things, the risk management will be scientifically you will be doing. So we are already doing hazard identification, everything. But you should have a lot of deliberation before going for SCORS meeting with all the stakeholders, brainstorming. We should keep different type of generation people, young people to senior people, experienced to inexperienced people, subject matter expert or some common man, whatever the way, because whomsoever you find that they will be part of the system and there's one way or other way, they should be part of the brainstorming. Then you will be able to identify clear risk management we can do. And obviously, once you do all these things, we will not waste our resources. We will be utilizing all our resources perfectly. So these are the principles of system engineering. So first what we have seen, we have just introduced the what is the system and what are the concepts behind the life cycle and what are the benefits it can give. And we also have seen certain key principles of system engineering.